This is lesson 9.4 about a quick linear function review. Number 1 says we just need to graph this and then state the slope and the y-intercept. If you notice, number 1a and b are also working with this same function. So I'm going to go from 1 to the graph to the a and b before I move on to question number 2. When we graph an equation that's in y equals mx plus b form, remember that f of x is the same as y. The number in front of x is your m, or your slope, and the last number without a variable is your b. As long as y is solved for, this is the form we're going to be graphing in. So let's look for the slope of this line, the number in front of x here. When there's no number shown, that number of course would be a 1. So my slope of this line is 1. The y-intercept is the number in the back without a variable, so that would be -2. When we graph these, we always start at our y-intercept, so we're going to put a point on the y-axis at -2. So that would be right here on my graph, y equals -2. Then from this point, I'm going to move in this fashion, this type of slope. If I were to write that as a fraction, that would be 1 over 1, which means I'm going to rise 1, go up 1, and then positive 1 in the x direction, which is right 1. So up 1, right 1. I can put a dot right there. I can continue to do this, up 1 over 1, until I fill out my entire graph. And then I can do the opposite, down 1, left 1, and continue this line this way. When you've got it all, go ahead and connect using a straight line. Make sure your line has arrows at the end and you've got the graph of the line. Before we move on to number 2, let's go ahead and analyze this function at these two spots. This is saying I plugged in a 1 into this function f. What did I get? There are two ways you can solve this. First, you could just look at the graph. I plugged in a 1. In other words, x, this number inside of here, is 1, so what is my y? If my x is 1, if I look at my graph and go 1 in the x direction, where is my y value, or where is my graph at? Isn't it at a y value of -1? I'm right there. So I think if I plug in a 1, I get a -1 in the picture. Another way you can do this is just go ahead and plug this -4 into the function above, just like we did with normal function notation. My original function is f of x equals x minus 2. Okay, again, I'm just getting that from up here. I want to figure out what f of -4 is, so write in -4 every place that you see an x, and then simplify. It really is -4 minus 2, so that's just -6. Number 2, we're going to solve the exact same way. We have a slope, the number in front of x is -1/3, and then my y-intercept is the last number, or 3. I'm going to start at that y-intercept of 3, start at a y-axis at 3, and then from there I'm going to go down 1, right 3. If I go down 1, right 3, I'm right here. Notice I'm going down 1 because it's -1 over 3. I could also go +1, -3, which would put me in this spot. Okay? Make sure you do not go -1, -3, because remember, a negative over a negative is a positive, so that won't work for the slope because the slope here should be negative. So we're ready to connect these dots. Make sure you connect them with a straight line and arrows on the end. Now let's go ahead and look at these two functions. I have the function g, I want to plug in -3. So if I went -3 in the x direction, that'd be right here. Where is my graph? It's at +1, 2, 3, 4, +4. You could also just do that by plugging in it to the original function. So if I'm at 0, my function is at 3. For part h, my slope here is the number in front of x, so 2, or you could write 2 over 1, and my y-intercept is the last number, -1. I'm ready to graph. I'll start at the y-intercept of -1, and then I will go up 2 and +1 until I have enough points to go ahead and graph a line here. I'm going to graph that line, put arrows at the end, and then if I look at where h is at, when my x is at -1, I'm right down here at -1, 2, 3, -3. And then at +2, I'm at +3. So -3, +3 for those ones. For the next one, we're just using our function notation to plug these values in. So we're going to plug in 3 into all of these functions. So the first one, I'm going to take f, and I'm going to plug in 3. So everywhere I see an x, I'm going to write a 3 instead. So for this first part, 2 times 3, that's going to give me 6. I have 6 minus 15. So f of 3 is going to be -9. Make sure you have your function notation there. I won't give full credit unless I have this part there in your answer as well. The next one, I'm still going to be plugging in 3, so f of 3 over here is going to be -3 plus 3, which would, of course, just equal out to 0. For g, I'm going to plug in 3 again. G of 3 equals 2/3 times 3 minus 1. These 3's are going to cancel out, and I just have 2/3, or 2, minus 1, so that's going to give me g of 3 is going to be just plain old 1. For the next, I'm still plugging in 3, h of 3. I'm going to take the negative, leave it alone, take the 3, square it, and plus the 4. You notice that I'm only squaring the 3, just the thing that I'm plugging in. So if I square that, I get 9, and then I still have a negative here. Again, the negative didn't change. The negative isn't getting squared. Just the x is getting squared there. So if I put those guys together, h of 3 is going to be -9 plus 4, which is -5. For g, plug in 3 again, g of 3, and I'm going to get -3 over 6 plus 3 halves. If I were to reduce this first fraction, this would be a 1 and this would be a 2, which is kind of nice, because that gives me -1/2 plus 3 halves, so we have common denominator, so I don't have to really worry about making a common denominator here. I know my denominator is going to stay at 2, and then I have -1 and 3, which gives +2, so that's going to be +2 divided by 2, which is of course just +1 here. Last but not least, I'm plugging in x. So this one already has x plugged in. We're going to take this and we're going to do -x squared, which means notice how now the negative is within the parentheses and actually getting squared. Just like over here where it wasn't. Here, just the 3 was being squared and then I stuck a negative on the end. Now we're doing this entire thing squared. So what's any negative squared? It's going to be -x times -x, so that's +x. This one is +x squared here. On the next, I'm plugging in these specific values. I'm going to first take f and plug in -7. So I'm doing 4 times -7 minus 2. 4 times -7 is going to give me -28. And then minus 2 gets me -30. For the next one, if I plug in -8, g of -8, I have -8 within absolute values. Absolute values are the distance away from 0, so in other words, get rid of that negative, but I still have this negative out here. So that means, again, this negative is staying, but then this guy gives me +8, but I still have the negative out front, and then +3. So -8 plus 3 is going to give me -5 for my total answer. For the next one, I'm plugging in 4. N of 4 is going to equal -1/2 times 4 squared plus 1. Let's take care of that 4 squared first. 4 squared is, of course, 16, so I'm going to do -1/2 times 16 plus 1. Now, what's 1/2 of 16? Well, it's 8, so it's going to be -8 altogether because I have 1/2 of 16, which is 8, and then of course a negative sign, and plus 1. -8 plus 1 is going to give me -7. Next, I'm working to graph some inequalities here. Before I can graph this one, I need to solve for y. So we need to get y by itself, so I think that I'm going to start by subtracting 5x from both sides. If I do that, that'll get us started with almost getting y by itself here. So that means all in all, I have 3y is less than or equal to -3 minus 5x. Next, I want to divide by this 3 to get the y completely by itself. And again, I suggest that you divide each individual number by 3, because now I can see over here that negative 3 divided by 3, well, that's just negative 1. And then I'm going to write this right here as negative 5/3 x. This is a super nice way to do it because now I have y equals mx plus b. I know that my b is the number without the variable, so I'm going to start at my y-intercept of negative 1, and then from there I'm going down 5 and positive 3. And then positive 3, so that's right here. Or I could go up 5 and negative 3. When I connect these dots, I want to use a solid line because this is less than or equal to. So I'm going to use a solid line and go ahead and draw your arrows at the end. I'm still not done. The next thing I need to do is color it in. So I need to color y is less than the graph, which means y is below the graph. So I think I'm going to color in this region down here. And there you go. There's the graph of this inequality. Any of these shaded points would be correct in answering that question. Any point you pick down here. Okay? On the next one, this one, oh nice, it's already solved for us. We already have y by itself, so we don't have to do much math. We're ready to graph. We'll start at y equals 3, our intercept of y equals 3. From there, I have this slope. Again, I could write this as negative 1 over 3 or positive 1 over negative 3, but make sure it's not negative over negative because this would be a positive fraction. I want to make sure my fraction stays negative. So let's try graphing this way. Negative 1, so I'll go down 1 and then positive 3. That would put me here. Or if I graph this way, I would go positive 1 and then negative 3. See how those both end up on the same line? That's totally fine. I can put my negative either at the top or at the bottom. Don't put it at both because that would not be the correct slope here. Now, when I connect these dots, I'm going to use a dotted line. That is because this guy is less than, just less than, it is not equal to. So because it's not equal to, I'm going to use just a dotted line here. So I'll connect these the same way as normal, but I'm just using a dotted line instead of a solid line. And I'm still going to put arrows at the end. Now I'm ready to color, and I'm going to color the part below the graph because y is less than. So we're going to go down here. Anywhere below this line is the correct answer. The last few are pretty simple. We're just going to write an equation. I know my equation is going to be in y equals mx plus b form. I really just need to know what is my slope and what is the y-intercept. So if I look at this question, my slope, let's look at that first. I'm starting here. I need to go up and over to get to here. So rise and run. I rise 1, 2, 3, 4. My rise is 4. And then that means I'm here. How much do I run? 1, 2, 3. I have to run 3, but I'm moving left. So that means I'm running a negative 3 because I have to move in the left direction. There's my slope, and then last, my y-intercept is just where this graph crosses the y-axis. So here's the y-axis. It crosses right there at 2. So that means my overall function is y equals m, which is that negative 4/3, x plus my b, which is 2. The next one is the same situation, y equals mx plus b, so let's first find our m, our slope. I need to connect these two. Again, start with your rise. How would you run? We rise 1, 2, 3, 4. I'm up 4. So I went up, so that's positive 4. And now I'm here and I need to go left 1. So to signify I'm going left, that would be a negative 1. I could rewrite this as just 4 divided by negative 1, well that's just negative 4. Here's my slope. My y-intercept, it looks like it's still just at 2 because my guy crosses the axis at 2. So y equals m of negative 4, x plus b, which is 2. For 17, I have my slope, which here, if I'm going down 1, 2, so that's a -2 for my slope. And then I need to run 1, 2, 3, 4. So -2/4, if I were to reduce that, that would just be -1/2. And then my y-intercept, it looks like it crosses the y-axis at 3. So here are my points. Y equals my slope of -1/2, x plus my b is 3. Last but not least, my slope. To connect these 2 points, I'm going to go up and then over. So I'm going up 1, 2, 3, 4, 5, 6, 7, 8. My slope starts with an 8 on top, and then I'm going to the right, so that's +2. Okay, and then 8 divided by 2, well, that could really just be written as 4. And then my y-intercept is down here, 1, 2, 3, -3, so my b is -3. So I have y equals 4x minus 3.